Hello students and good afternoon. So today I am doing class for class 12 science. The topic is first order derivative. So in the last class also we were doing the same topic, that is first order derivative. So this is the continuation class, right? So same exercise 3A, page number 292, and here also each question carries 2 marks, right? So find the derivatives with respect to x. So we will continue the problem now. So 11 number 1, you have to find out the derivatives of this function with respect to x. So question number 11 number 1 is log within bracket cosec x plus cot x. You have to find out its derivative. Let us assume y is equal to log within bracket cosec x plus cot x. So now let's find out dy by dx. That means you have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore dy by dx is equal to d by dx of, within second bracket, let us write log cosec x plus cot x. That means we are differentiating log within bracket cosec x plus cot x with respect to x. Okay, so or dy by dx is equal to, how can we differentiate this log within bracket cosec x plus cot x? So first of all, log is given, that means you should take it as log x. Okay, so you know the differentiation of log x, isn't it? So what is the differentiation of log x? It is 1 upon x. So 1 upon, what is the value for x out here? So within bracket cosec x plus cot x, right, into. Now which function is assumed as x here? Cosec x plus cot x. The function which is assumed as x is also to be differentiated, right? That is, you have to differentiate the function which is assumed as x. So into d by dx of, within first bracket, cosec x plus cot x. Is that clear now? So now let us simplify it. Therefore dy by dx, so the fraction here is 1 upon, so it remains same, 1 upon, it is cosec x plus cot x into, now let us write it within third bracket. So you have to differentiate cosec x plus cot x with respect to x. Now you should know the formula, right? What is d by dx of cosec x? It is minus cosec x cot x, minus cosec x into cot x, right? Then what is the differentiation of cot x? It is minus cosec square x. So let us write here minus cosec square x, that is minus cosec x cot x minus cosec square x. Okay, now let's simplify it. Or dy by dx is equal to 1 upon, in the denominator it is cosec x plus cot x into. So now let's simplify. You can take common out there. What is common there? Minus cosec x. Minus cosec x is taken common. So within bracket, what do we get? It is cot x minus into minus. So this is minus sign here. So minus into minus is plus. And cosec x is taken common out here. So plus. So since there is no space there, write it in the next step, that is cosec x plus cosec x, bracket is closed. Is that clear? So now this is cot x plus cosec x. This is also cosec x plus cot x, which is in the denominator. You can cancel it. That means you can divide it. Right? So what is the answer now? Or dy by dx is equal to, the final answer is minus cosec x. So what is the differentiation of this function with respect to x? It is minus cosec x. So this is the final answer. Is that understood now? So you can copy it. So we'll do the next question now. So now we will do the next question, that is element number 2. So it is given, find the derivatives of log within bracket x plus root under x square plus a square with respect to x. So you have to differentiate this function. So here also let us assume y is equal to log within bracket x plus root under x square plus a square, right? So this is an important question. So let us find out dy by dx now. So let us write differentiating both the sides with respect to x. Therefore, dy by dx is equal to d by dx of within second bracket log of within first bracket x plus root over x square plus a square. So second bracket is closed. So how can we differentiate it again? Log of x, which function is taken as x? X plus root under x square plus a square is taken as x. So first of all, log is given, that's why you should take it as log x to differentiate it with respect to x. Okay, so or dy by dx is equal to, now this is log x form. So what is the differentiation of log x? 1 upon x plus root over x square plus a square into, again you have to differentiate the function which is assumed as x. That is, which function is assumed as x? X plus root under x square plus a square. That is also to be differentiated. That means d by dx of x plus root over x square plus a square. Right? Again you have to differentiate the function which is assumed as x. So in this case, x plus root under x square plus a square is assumed as x. That's why we are differentiating x plus root under x square plus a square. Right? So now let us differentiate it. Or dy by dx is equal to 1 upon, in the denominator, x plus root over x square plus a square into, now within third bracket, let us write it within third bracket. So what is d by dx of x? You know that it is 1, right? 1 plus, now you have to differentiate d by dx of within square root x square plus a square. So how will you differentiate it? Which function will you take it as x? Okay, so d by dx of root over x square plus a root over x square plus a square is there. Now which function is taken as x? You should take it as d by dx of root over x. You know that what is d by dx of root over x? There is a formula 1 by 2 root x. Here which function is taken as x? X square plus a square. And again you have to differentiate the function which is termed as x. Okay. So what is d by dx of root over x? It is 1 by 2 root over x square plus a square, right? Actually it is 1 by 2 root over x, but you cannot write x there because x here is x square plus a square. Now again you have to differentiate the function which is assumed as x, that is you have to differentiate x square plus a square. Okay, so into d by dx of x square plus a square, that is third bracket is closed. Is that clear to all of you? So you have to write down the differentiation of these two functions within third bracket. If you don't write third bracket, there might be some mistakes out there. Okay, so while differentiating x plus root over x square plus a square, you have to write down their differentiation within this third bracket or within second bracket or within first bracket. Okay, so now or dy by dx is equal to 1 upon x plus root under x square plus a square into within third bracket. Now it is 1 plus 1 upon 2 root over x square plus a square into, what is d by dx of x square plus a square? First of all, you have to differentiate x square with respect to x. What is it? 2 comes in the front. Decrease the power of x by 1. That is 2 minus 1. That is 1. X to power 1 by you. So it is x only. But what is d by dx of a square? But a square is constant. because this is free from x. So it is a constant quantity. What is d by dx of a square? That is 0. That is 2x plus 0 is always 2x. You know that, isn't it? So you don't have to write that 0, right? So now in this case, these two will be cancelled. Or dy by dx is equal to 1 upon x plus root over x square plus a square into within third bracket now. So what's the LCM here? The LCM here is root over x square plus a square, right? So here 2 gets cancels. The LCM is, now below 1 there is 1, you know that. And what's the LCM of 1 and root over x square plus a square? That is root over x square plus a square. Now this LCM is divided by 1. You'll get root over x square plus a square, and it should be multiplied by the numerator, that is 1. So what do we get? Root over x square plus a square plus. Now again this LCM is divided by this denominator, root over x square plus a, that is 1. So 1 should be multiplied by x. What is 1 into x? That is x. Clear? So you can cancel it. This is 1, 1, right? So this is 1, 1. So what is the final answer now? So dy by dx is equal to 1 upon, it is root over x square plus a square. So this is the final answer. So this is very, very important question. So now we'll do the next question. Now we are doing question number 11.4. This is also find the derivatives with respect to x. The given function is log tan of within bracket pi by 4 plus x by 2. So this is also an important question. So let us assume let y is equal to log tan of within bracket pi by 4 plus x by 2. So here also, while differentiating, you should take it as log x, because the first function given here is log, isn't it? So differentiating both the sides with respect to x, right? So therefore dy by dx is equal to d by dx of within second bracket log tan within first bracket, it is pi by 4 plus x by 2, right? So or dy by dx is equal to, now you have to differentiate log tan within bracket pi by 4 plus x by 2 with respect to x. So why differentiate this function? Let us take it as log x, because the first function given here is log. So you should take it as log x, because you know the differentiation of log x, isn't it? What is the differentiation of log x? It is 1 upon x. But which function is taken as x here? Tan within bracket pi by 4 plus x by 2, right? So log x differentiation is 1 upon x, but what is x here? It is tan within bracket pi by 4 plus x by 2, right? Again you have to differentiate the function which is assumed as x, right? So which function is assumed as x? Tan of pi by 4 plus x by 2, right? So therefore d by dx of tan of within bracket pi by 4 plus x by 2. So that is your differentiation, okay? So now next, or dy by dx is equal to, so it is 1 by tan within bracket pi by 4 plus x by 2 into. Now how can you differentiate tan within bracket pi by 4 plus x by 2 with respect to x? What should you take it as? First of all, tan is given. You should take it as tan x, because you know the formula of tan x. What is the formula for tan x? It is sec square x, you know that. Now in this case, which function is taken as x? It is pi by 4 plus x by 2, right? So what is the differentiation of tan x? It is sec square x. But in this case, you should write sec square, what is x in this case? Pi by 4 plus x by 2. Pi by 4 plus x by 2 into, now again you have to differentiate the function which is assumed as x. Which function is assumed as x? Pi by 4 plus x by 2, right? So you should write dy dx of pi by 4 plus x by 2. So this is the differentiation of the function, right? So let us simplify it now. Or it is dy by dx is equal, let us convert it into sin and cos. 1 by 10 means you know that it is cot. Cot is cos by sin. Let us simplify it. Cos pi by 4 plus x by 2 divided by, it is sin pi by 4 plus x by 2. Is that clear? Next, into, what is sec square in terms of cos? It is 1 by, this is your cos square pi by 4 plus x by 2, right? Into, now you have to differentiate pi by 4 plus x by 2 with respect to x, right? So what is dy dx of pi by 4? It is 0 because that is constant. Pi by 4 is free from x, so it is a constant. So what is dy dx of constant? It is always 0. But plus, what is dy dx of x by 2? So which is constant here? Half is constant. Now you should take it outside d by dx. So it is half into, because this half is with the variable x, right? So half is taken outside d by dx. So you have to differentiate x with respect to x only now. dy dx of x. Is that clear? So what is dy dx of x by 2? Half is constant, it is taken outside. Half into, then you should write dy dx of x. Is that clear? So now let us simplify it. Cos pi by 4 plus x by 2, and this square gets cancels. So it remains only cos of pi by 4 plus x by 2, right? So or dy by dx is equal to, now what is dy dx of x? You know that it is 1, isn't it? So multiply all these ones in the numerator, you will get 1 whole divided by, in the denominator, this dy dx of x is always 1. dy dx of x is 1, right? So these 2 comes in the front, in the denominator, 2, write down 2. Then sin pi by 4 plus x by 2, right, into cos of pi by 4 plus x by 2. Is that clear? So now let us simplify. You can simplify it further. You can do further simplification here. Or dy by dx is equal to, so 1 upon, which formula is used in this case? Pi by 4 plus x by 2, pi by 4 plus x by 2. Same angles are there, isn't it? It is 2 sin a cos a. So you know from multiple angles, what is 2 sin a cos a? It is sin 2a. So it is sin 2 into what is a? Pi by 4 plus x by 2. That is sin 2a form. Sin 2, what is a here? It is pi by 4 plus x by 2. Or dy by dx is equal to 1 upon sin, within bracket, multiply by 2 out here. So what is 2 into pi by 4? It is pi by 2 plus, what is 2 into x by 2? 2 gets cancelled, you will get only x. So it is sin pi by 2 plus x. Or dy by dx is equal to 1 upon, what is the formula for sin 90 degree plus x? Pi by 2 in sexagesimal system is 90 degree. So sin 90 degree plus x. So the angle 90 degree plus x lies in the second quadrant. And in the second quadrant, sign is always positive. So usually we don't write positive sign. But pi by 2 is 90 degree. 90 degree means 90 degree into 1. So it is odd multiple of 90. So it is, if it is odd multiple of 90, this sign changes to cos. So it will be 1 by cos x, right? So what is 1 by cos x? What is the simplified form of 1 by cos x? It is sec x. So this is the final answer. So this question is very, very important. So now we'll do the next question. So now we'll do the next question. Find the derivatives with respect to x of the function sec to the power nx. This is tool number 1. Sec to the power n, then x. Let us assume let y is equal to sec to the power n x. Since the power n is constant here, let us write it within whole to the power n. That is sec x whole to the power n, right? So y is equal to sec x whole to the power n. So if you write it within whole to the power n, you will understand how it can be differentiated. Okay? So differentiating both the sides with respect to x, right? So therefore dy by dx is equal to d by dx of sec x whole to the power n. So if it is given whole to the power n and n is a constant quantity, so you should take it as x to the power n while differentiating it. So which function is taken as x? Sec x. Okay? So you should take it as x to the power n. So you know the differentiation of x to the power n, isn't it? What is the differentiation of x to the power n? N into x to the power n minus 1. So, or dy by dx, so n comes in the front, x is taken as sec x. So within bracket, you write sec x whole to the power n minus 1 into. Now which function is taken as x? Sec x. That function is also to be differentiated. You have to again differentiate the function which is assumed as x. So sec x is assumed as x. That you have to differentiate it. Okay? So that is d by dx of sec x. Again you have to differentiate the function x. Again you have to differentiate the function which is assumed as x. That is sec x was assumed as x. That means sec x is also to be differentiated with respect to x. Okay? So or dy by dx. So dy by dx is equal to, so n into this is sec x whole to the power n minus 1 into, what is d by dx of sec x? It is sec x tan x. Okay? It is sec x into tan x. Right? Because you know the formula for d by dx of sec x. It is sec x into tan x. Right? So or dy by dx. Now again we can simplify it, n into, what is sec x whole to the power n minus 1 into sec x? These two can be multiplied. Sec x means sec x whole to the power 1. So if you multiply these two sec x, powers will be added. So what do we get? Sec x whole to the power n minus 1 plus 1. That means 1 gets cancelled. So you will get sec x whole to the power n into what? It is tan x. Right? So let us write down the final answer. So dy by dx is equal to n into, you can write it as sec to the power nx into what? Into tan x. So this is the answer. So you can copy it. We'll do the next question now. So now we will do question number 12, 6. Okay. So you have to find out the derivatives with respect to x. The given function is cos inverse x upon a whole cube. So let us write, let y is equal to cos inverse x upon a whole cube. That means you have to find out dy by dx. So write down differentiating both the sides. Differentiating both the sides with respect to x. So therefore dy by dx is equal to d by dx of, this is cos inverse x upon a whole cube, right? So how will you differentiate it? Here the power given is constant. This base cos inverse x by a, there is x, so this is the variable. So you should take it as x to the power n. So if you want to differentiate it, you should take it as x to the power n. That means which function is taken as x? Cos inverse x upon a. Okay, so that is the function x to the power n. You know what is the differentiation of x to the power n with respect to x, isn't it? That is n into x to the power n minus 1. So here also, or dy by dx is equal to, its differentiation is 3 comes in the front. Then what is x here? You can't write x, but what is the value for x? You have to write cos inverse x upon a whole to the power 2. You have to decrease the power by 1. That is 3 minus 1 is 2. Now which function was assumed as x? It is cos inverse x by a, isn't it? That function is also to be differentiated. That is, you have to differentiate the function which is assumed as x. That is, cos inverse x by a should also be differentiated. So that is d by dx of what? Cos inverse x upon a. Is that clear now? So now in the next step, or dy by dx is equal to, this is 3 into cos inverse x upon a whole square into dot. That means into. Now how will you differentiate d by dx of cos inverse x by a? You should take it as, first of all, the inverse circular function is given, that is cos inverse. You should take it as cos inverse x now. Which function is taken as x now? X by a. So you should take it as cos inverse x. So what is the differentiation of cos inverse x? You know that. Let us write multiplication sign, minus 1 upon root over 1 minus, what is x whole square in this case? So here x is x by a, so you should write x by a whole square. But is it the only differentiation? No. You have to differentiate the function which is assumed as x. Which function was assumed as x? That is x by a. So x by a should also be differentiated. That means into d by dx of what? X upon a. Is that clear? You should differentiate x by a with respect to x. So don't forget to differentiate x by a also with respect to x. Okay. Now let us simplify it. Or dy by dx is equal to, minus sign comes in the front. So right, minus 3 into cos inverse x upon a, this is whole square, into 1 upon within square root 1 minus what is x upon a whole square, that is x square upon a square, into now d by dx of x by a. How will you differentiate? There is a constant term there. One of the term is constant out there, that is 1 by a. So it should be taken outside. So 1 upon a into d by dx of x. So what is d by dx of x? That is always 1, right? So let us simplify it. Or dy by dx is equal to minus 3 into cos inverse x upon a whole square into 1 upon within square root. What's the LCM? It is a square, right? So in this case, so above denominator, what is the term there? A square into 1 is a square minus x square into 1 by a into, what is d by dx of x? It's always 1. Is that clear? So let us simplify it. Now next, or dy by dx is equal to minus 3 into cos inverse x upon a whole square into, now in the denominator there is a square, but it is always square root. What is square root of a square? A. But since it is below denominator, when it goes up in the numerator, it becomes a upon, isn't it? So square root of a square is a. So a goes up in the numerator. A divided by, it is root over a square minus x square, right? Into, what is 1 by a into 1? That is 1 by a. So here this a gets cancels. So write down the final answer now. What is dy by dx is equal to minus 3 into cos inverse x upon a whole square, whole divided by what? That is root over a square minus x square. So this is the final answer. Understood? So you can copy it. We'll do the next question now. Now, we'll do the next question, that is 30 number 1. Find the derivatives with respect to x of the function cos x cubed sine square x to the power 5. Okay. So let us write, let y is equal to cos x cubed into sine square x to the power 5. Now, in this case, cos x cube is there, but you cannot write it within cos x whole cube. Within bracket cos x whole cube, you cannot write it because this power 3 is for only x, not for cos. But this is for, this square is for sine, so you can write it within whole square. That is sine x to the power 5 whole square, right? So in this case, or y is equal to cos x cube, you cannot write here cos x whole cube because this power 3 is for only x, not for cos. But you can write here sine x to the power 5 second bracket close whole square. If it is sine square, then you can write it within whole square, right? So let us differentiate it. So write down differentiating both the sides, with respect to x, right? So therefore dy by dx is equal to, so this is the product of two functions. So you should write down here differentiation of the product of the two functions. You know that, isn't it? So you know that the formula dy dx of uv is known as the product rule. If u and v are two different functions of x, how can you differentiate uv with respect to x? Here uv is not constant. These are, u and v are two different functions of x. So you know this formula, you have done this formula in class 11, right? So what is the formula? This is known as the product rule. Let us keep y as it is into dy dx of v. So here the first function is taken as it is and take the differentiation of the second function, that is dy dx of v plus. Now the second function is taken as it is. You write it as it is v into, take the differentiation of u with respect to x, that is dy dx of u. So you should have done it in class 11. Okay? So class 11 I think you have done it in class 11. So dy dx of uv is equal to u remains same into dy dx of v plus v remains same into dy dx of u. So similarly you can use here. So cos x cube, it is kept as it is into dy dx of, within second bracket sine x to the power 5 second bracket close whole square. Now plus which function is kept as it is now? That is sine x to the power 5 second bracket close whole square into dy dx of what? First function, that is cos x cube. Is that clear to all of you? So we are using this product rule out here, right? Now let us simplify it. So or dy by dx is equal to cos x cube remains same into, now how do you differentiate it? Whole square is constant. Sin x to the power 5 is the variable, so you should take it as x to the power n. What is the differentiation of x to the power n? N into x to the power n minus 1. That means here n is 2. So into 2 comes in the front. Then what is x? Sine x to the power 5, right? Again into which function is taken as x here? Sine x to the power 5. So you should differentiate the function which is assumed as x. That is, you have to differentiate sine x to the power 5 again into d by dx of sine x to the power 5. Is that clear now? So now plus second term. So sine x to the power 5 whole square remains same. Sine x to the power 5 second bracket close whole square remains same into, how do you differentiate d by d? How can you differentiate cos x cube with respect to x? You should take it as cos x now because it is given x cube only. So you should take it as cos x. What is the differentiation of cos x? Into cos x differentiation is minus sin x, but here it is minus sin x cube into which function was taken as x? X cube. Now you should differentiate x cube with respect to x. That means d by dx of x cube. Is that clear now? So I think you have understood it. So or dy by dx is equal to, this is cos x cube into 2 sine x to the power 5 into. Now how do you differentiate sine x to the power 5 with respect to x? It is just like your sine x. Which function is taken as x? X to the power 5, right? So what is the differentiation of sine x? It is cos x. That means cos x to the power 5 into, again you have to differentiate the term which is assumed as x. In this case, which term was assumed as x? X to the power 5. So you should differentiate x to the power 5 with respect to x. Right? So now it is plus or minus. Minus, can multiply them. So now here it is sine square, you can simplify it. So it is sine square, this is your x to the power 5 into, this is sine x cube into, what is the differentiation of x cube with respect to x? It is 3x square. Is that clear now? So let us simplify it again. Or dy by dx is equal to cos x cube. So now, in this case, this is 2 sine a cos a, isn't it? These two are same angles. So you can use the formula 2 sine a cos a, right? So keep it within second bracket. So this is the formula 2 sine a cos a. What is the formula? Sine 2a. Sine 2a. That is sine 2x to the power 5. That is your formula from multiple angles. Is that clear? Into, what is d by dx of x to the power 5? It is 5x to the power 4. Is that clear? Next, now write down these 3 first. Then write down x square, right? Then sine square. This is sine square. X to the power 5 into, it is sine x cube. So here also, or you can write, so dy by dx is equal to, first you write this function, that is 5x to the power 4 into cos x cube into sine of, within bracket, 2x to the power 5. Then what is the second term? Minus 3x square. This is your sine square, x to the power 5 into, this is your sine x cube. So this is the final answer. Is it clear now? So you can copy it. Now we'll do the next question again. So now we'll do the next question, that is 13, number 2. Find the derivatives with respect to x of the function sine inverse 2x upon 1 plus x square. So let us assume it as y. So you have to find out dy by dx. So you know that this is the problem of inverse circular function, isn't it? So if you know the formula, you can directly write it. Otherwise, if you don't know the formula, you should derive it. Okay. That is, you know that this formula is 2 tan inverse x. But if you don't know the formula, then you can derive it. Okay. So you cannot differentiate it directly. Don't take sine inverse x directly here, because it will be complicated while differentiating. Okay. Because in this case, you know, this is from inverse circular function, and you can use the formula in this case, right? So let's do trigonometric substitution. So what should you put for x? You know that x is equal to what? Tan theta. If you put x equal to tan theta, what do you get? 2 tan theta upon 1 plus tan square theta, which is equal to sine 2 theta. You know that, isn't it? And what is sine inverse sine 2 theta? That is 2 theta. So it is simplified, isn't it? You will get this sine inverse 2x upon 1 plus x square in a simplified form, so that you can differentiate it easily. Is that clear? So let x is equal to tan theta. Suppose we don't know the formula, right? So get the value for theta. What is theta is equal to? This is your tan inverse x. So therefore y is equal to sine inverse within bracket 2 tan theta divided by 1 plus tan square theta. Is it clear? So what is the formula for 2 tan theta upon 1 plus tan square theta? It is sine 2 theta. You know that from multiple angles in trigonometry, right? So y is equal to sine inverse within bracket, you should write here sine 2 theta. Is that clear? So what is sine inverse sine 2 theta? That is 2 theta. Okay. So therefore y is equal to, this is your 2 theta. Is that clear? Now you have to put the value for theta. What is the value for theta here? Tan inverse x. So or y is equal to, this is your tan inverse x. That is sine inverse 2x upon 1 plus x square is equal to, what is it? It is 2 tan inverse x. So this is the function, this is the simplest function that you can differentiate it, isn't it? तर यदि तिमीले यसलाई डिफरेन्शिएट गर्दा कम्प्लिकेटेड हुँदैन. If you differentiate sine inverse 2x upon 1 plus x square, it will be complicated, isn't it? But if you write 2 tan inverse x instead of sine inverse 2x upon 1 plus x square, it will be easier for you to differentiate that function, that is 2 tan inverse x. Is that clear? So let us differentiate it. So differentiating both the sides, with respect to x, right? So therefore what do we get? Dy by dx is 2 is constant and it is with the variable tan inverse x. So you should write 2 before d by dx. So d by dx of this is your tan inverse x. Clear? So or dy by dx is equal to 2 into, what is d by dx of tan inverse x? You know the formula, isn't it? It is 1 upon 1 plus x square. Or dy by dx is equal to, this is 2 divided by 1 plus x square. So this is the final answer. So this is also an important question, right? So you can copy it. Let's do the next question now. So now we'll do next question, that is 13 number 3. So you have to find out the derivatives with respect to x of the function sine inverse e to the power x square. But in this case you cannot simplify it. You cannot write down the formula in this case. Directly you have to differentiate it as sine inverse x. You should take it as sine inverse x. So which function is taken as x? E to the power x square, right? So let us write, let y is equal to sine inverse e to the power x square. Now let us differentiate it with respect to x. So write down differentiating both the sides with respect to x, right? So therefore dy by dx is equal to d by dx of within second bracket sine inverse e to the power x squared. Second bracket is closed. Now how will you differentiate this sine inverse e to the power x squared with respect to x? You should take it as sine inverse x. First of all, inverse circular function is given out here, isn't it? So you should take it as sine inverse x. What is the differentiation of sine inverse x? 1 upon root over 1 minus x squared. So what is x here? E to the power x squared. So dy by dx is equal to, this is sine inverse x form, 1 upon root over 1 minus e to the power x square whole square. That is, what is the differentiation of sine inverse x? 1 upon root over 1 minus x square. But what is x here? You should write down the value for x in this case, e to the power x square. But this is not the only differentiation. You have to differentiate the function which is assumed as x. Which function is assumed as x? E to the power x square. So, यसलाई हामी फेरि डिफरेन्शिएट गर्छौं इन्टु कति हुन्छ d by dx of e to the power x square. Is that clear now? Now let us simplify it once again. Or dy by dx is equal to 1 upon within square root 1 minus, how will you simplify it? E to the power x square whole square. Both are in the power here, x square and 2. You can multiply them, right? So e to the power 2x square. It is e to the power 2x square, right? So e to the power x square whole square means these two powers, x square and 2, must be multiplied. Right? So it is e to the power 2x square into, so how do you differentiate this one? What is the differentiation of e to the power x square with respect to x? You should take it as, first of all, exponential function is there. That is e to the power x. Which function is taken as x? X square. So what is the differentiation of e to the power x here? It is e to the power x. But what is x here? X square into, again you have to differentiate the function which is assumed as x. That is, you have to differentiate x square also. D by dx of x square. Is that clear? So, or this is your dy by dx is equal to 1 upon root over e to the power root over 1 minus e to the power 2x square into e to the power x square into, what is d by dx of x square? You know that it is 2x. So it is 2x, right? So, or dy by dx is equal to, now what is the numerator there? You can simplify it. 1 into e to the power x square and 2x is 2x e to the power x square whole divided by, now within square root you write 1 minus e to the power 2x square. So this is the final answer. So you can copy it. We'll do the next question now. Now we'll do the next question. That is, this is 13 number 4, right? So this is question number 13 number 4. Find the derivatives of the function cos inverse within bracket 1 minus x upon 1 plus x with respect to x. So let us assume this function as y, and let's get the value for dy by dx. That means you have to differentiate both the sides with respect to x. But in this case, you can simplify this inverse circular function. You should do the trigonometric substitution here, right? So what should you put for x here? What should you put for x here? So that we can write it in the form of cos inverse cos theta, or it may be cos 2 theta, it may be cos 3 theta, okay? So x is equal to कति हाल्यो भने चाहिँ यो cos inverse cos theta or cos 2 theta हुन सक्छ. So you know that You know that the formula for cos 2 theta is equal to, what is the formula? So 1 minus tan square theta divided by 1 plus tan square theta. You know this formula from multiple angles, isn't it? In trigonometry, you have done it in class 11. But here it is only x is given out here. So you should put x is equal to what? Tan square theta. You have to put x is equal to tan square theta. If you put x is equal to tan square theta, then it will be 1 minus tan square theta upon 1 plus tan square theta, which is equal to cos 2 theta. So it is, what is cos inverse cos 2 theta? That is your 2 theta, right? So let us assume, let x is equal to tan square theta. So let us get the value for theta from here. That is tan theta is equal to root x. What is tan theta is equal to? It will be root over x. First of all, in order to get the value for theta, you should get the value for tan theta first. So tan theta is equal to root x. So what is the value for theta? So theta is equal to tan inverse root x. Is that clear? So now this y now becomes, so y is equal to cos inverse within bracket 1 minus, what is x in this case? What is x in this case? What is x here? Tan square theta. 1 minus tan square theta upon 1 plus tan square theta. Alright? So what is the formula for 1 minus tan square theta upon 1 plus tan square theta? It is cos 2 theta, right? You can use this formula now. So right now, so therefore y is equal to cos inverse within first bracket, it is cos 2 theta. So is it clear now? So what is cos inverse cos 2 theta? It is only 2 theta, you know, from inverse of the function, isn't it? So y is equal to, this is your 2 theta. Now let us put the value for theta, because you have to write theta in terms of x, because we are simplifying the term containing x here. That is, we are simplifying 1 minus x upon 1 plus x. So you should write down this theta in terms of x here also. Oh, yes, you have to express theta in terms of x. So what is theta here? Tan inverse root x, or y is equal to 2 tan inverse root over x. Now this is the simplified term, that is tan inverse root over x, which can be easily differentiated. Clear? So right now, differentiating both the sides with respect to x. Differentiating both the sides. Differentiating both the sides with respect to what? With respect to x. Now let us differentiate it. So therefore dy by dx is equal to, now this constant 2 is with the variable. So you should write 2 before d by dx. That means 2 into d by dx of tan inverse root over x. Now how can you differentiate tan inverse root over x? Let us take it as tan inverse x only. So we are taking root over x as x. Now let us differentiate it. So dy by dx is equal to 2 into, what is the differentiation of tan inverse root over x with respect to x? It is 1 upon 1 plus x square will be there. But you cannot write here x square. But what is the value for x in this case? That is root over x. So it is root over x whole square into, again differentiate the function which is assumed as x. So हामीले कुन चाहिँलाई चाहिँ x सम्झेको root over x लाई त्यसलाई हामी फेरि के गर्नुपर्छ? Differentiate गर्नुपर्छ. That is d by dx of root over x. So I think you have understood it. बुझ्यो हैन सबैले यो? So now next, let us simplify it again. Or dy by dx is, so this is 2 ones are 2 divided by 1 plus root over x whole square is x into, what is d by dx of root over x? You know the formula. Direct formula is there, isn't it? What is d by dx of root over x? 1 by 2 root over x. So here 2 gets cancels. So dy by dx is, what is the final answer? This is 1. This is also 1. 2 ones are 2, 2 ones are 2, right? So 1 ones are 1 divided by root over x, and within bracket you should write 1 plus x. So this is the final answer. That is root over x into 1 plus x, and in the numerator there is 1, right? So this is the final answer. So we'll do the next question now. So now we are doing the next question, that is 13 number 5. 5 of question number 13, right? Find the derivatives of sine 4x cos x with respect to x. So let us assume y is equal to sine 4x into cos x. You can differentiate it directly also. You can use d by dx of ub rule. D by dx of ub. That is, you can use product rule here. But I suggest you to use the formula in this case. Which formula is used? You know, in trigonometry, transformation of products and sums, like 2 sin a sin b, 2 sin a cos b, 2 cos a sin b, 2 cos a cos b, and so on, right? So this is your sin a cos b. Take the greater angle as a. 4x is greater than x, isn't it? So 4x is taken as a and x is taken as b. So this is your sin a cos b. Okay? But you know the formula from transformation of products and sums, that is 2 sin a cos b. So I think you know this formula. That is from transformation of products and sums. You have done it in trigonometry in class 11, right? So what is 2 sin a cos b formula? It is sine of a plus b plus sine of a minus b. And always you should take the greater angle as a and the smaller angle as b. Okay? So now, or y is equal to, we need 2 out here, then only you can use this formula. So how can you write down 2 out there? Half into 2, because that 2 should be cancelled. So you should write half into 2. So it will be half into 2 sine 4x into cos x, right? Or y is equal to half, now within bracket. So here a is 4x and b is x, isn't it? What is sine of a plus b now? So this is sine of, what is a plus b now? That is 4x plus x, that is 5x. Again plus sign is there. Sine of, what is a minus b? It is 4x minus x, which is 3x. 4x minus x is 3x. Okay? Now, this will be easier for you to differentiate now. Okay? So, first of all, multiply by half here. So, y is equal to half sine 5x plus half sine 3x. Is that clear? So, now let us differentiate this function with respect to x. Right? So, right now, differentiating both the sides with respect to x, right? So therefore dy by dx is equal to, half is constant, you can write it before dy by dx, half dy by dx of within bracket sine 5x. This is your sine 5x plus, what is the second term? Also half is with the variable. You write half first into what? That is d by dx of, what is here? It is sine 3x. It is sine 3x. Is that clear? Or this is your dy by dx is equal to half into, what is d by dx of sine 5x? How will you differentiate it? Sine 5x, now this is taken as sine x. So which is taken as x? 5x. What is the differentiation of sine x? It is cos x, but here it is cos 5x into, again you have to differentiate the function which is assumed as x. That is 5x is also to be differentiated with respect to x. That means d by dx of 5x. Is that clear? Next, plus half into, similarly you can differentiate sine 3x. So what is the differentiation of sine 3x? It is cos 3x into what? d by dx of 3x, because dx is taken as x. So d by dx of what? That is 3x. Is that clear? So, or dy by dx. Now you tell me, what is d by dx of 5x? 5 comes in the front because it is constant. 5 comes before d by dx. Then it is d by dx of x is always 1. So what is d by dx of 5x? It is only 5. So it is 5 by 2 cos 5x plus again, what is d by dx of 3x? 3 is constant. You can write it before d by dx. So it is 3 by 2 and cos 3x. What remains here? D by dx of x. What is d by dx of x? That is always 1. So into 1 you don't have to write it. So this is your final answer. Is that understood now? So you can copy it. Let's do the next question. Now, we'll do the next question, that is 13 number 7. You have to find out the derivatives with respect to x of the function e to the power ax cos bx. Differentiate. So let us assume y is equal to e to the power x cos bx. This is the product of two different functions. But in this case, neither you can simplify it nor you can use the formula here. Okay? But in this case, you have to directly differentiate it with the help of product rule, UV rule. You know UV rule, isn't it? So let us differentiate it directly with respect to x. That is differentiating both the sides with respect to x. So therefore dy by dx is equal, let us use UV rule here. You know UV rule, isn't it? So e to the power ax into d by dx of, this is your cos bx plus. Now which constant will you keep same? That is cos bx. Now you have to differentiate d by dx of, that is the first term, that is e to the power ax. Is that clear? So or this is dy by dx is equal to e to the power ax into. Now how do you differentiate it? How do you differentiate cos bx with respect to x? Let us take it as cos x. What is the differentiation of cos x? It is minus sin x. Which function is taken as x? Bx. So here it is minus sin bx. Again differentiate the term which is assumed as x, that is d by dx of, you should write here bx. Is that clear? Next, plus cos bx. How will you differentiate d by dx of e to the power ax? You should take it as e to the power x. What is the differentiation of e to the power x? It is e to the power, what is x here? It is ax. That is ax is taken as x. Again you have to differentiate the term which is assumed as x. That is, you have to differentiate ax with respect to x. Is that clear? So now let us simplify it. Or dy by dx. So write down first minus e to the power ax into sin bx into, what is d by dx of bx? Since b is with the variable, b comes in the front of d by dx, and what is d by dx of x? It is 1. So it is only b, right? Next, plus this is cos bx into e to the power ax into, what is d by dx of ax? Here a is constant, but it is with the variable x. So a comes in the front of d by dx. A like d by dx already given. And what is d by dx of x? Always 1. So it is only a, right? So or you can write here dy by dx is equal to minus, let us write b first, e to the power ax into sin bx plus, let us write a first here, then e to the power ax, then write on cos bx. So this is your answer. Or you may simplify it further. Or dy by dx, what is common out here from these two terms? E to the power ax. Now within bracket, let us write down the positive term first. That is a cos bx. This is a cos bx, then minus e to the power ax is taken common out here, so it is minus b sine bx. It is minus b sine bx. So this is the final answer. Understood? So you can copy it. So there is similar type of problem. I'll give you the similar type of problem here. So you do find the derivatives. Find the derivative of e to the power ax into sine bx. E to the power ax into sine bx. Right? In this problem, cos bx was given. So I have written here sine bx. Right? So this is your homework. You can do it at home. Find the derivative of e to the power ax sine bx with respect to x. Similarly, you can do this problem. तिमीले यो अगाडिको जस्तै पाराले यो क्वेशनको आन्सर गर्न सक्छौ. That is, you have to find out the derivative of e to the power ax into sine bx with respect to x, as you can use the same method that we have done in the previous one. Okay, so you can do it at home, right? So let's do the next question now. You can copy that question. That is, find the derivative of e to the power ax into sine bx with respect to x. So now we will do 13 number 8. That is, find the derivatives of sin x, sin 2x, sin 3x with respect to x. Okay. So in this case also, let us use the formula from transformation of products and sums. Right. So before that, let us write it as y. Let y is equal to sin x, sin 2x into sin 3x. Now in this case, which formula is used from transformation of products and sums? That is 2 sin A sin B, right? What is the formula for 2 sin A sin? In this case, you can use 2 sin A sin B. Okay. So what is the formula? It is cos of A minus B minus cos of A plus B, right? What is the formula for 2 sin A sin B? It is cos of A minus B minus cos of A plus B. This is the formula. Okay. So always take A greater than B. So let us take only two terms first. So which two terms will you take first? You can take either sin x sin 2x, or it may be sin 2x sin 3x, or it may be sin x sin 3x, like that. Okay. So which two functions will you take first? So let us take sin x and sin 2x. But which one is greater? This 2x is greater than x. Let us take 2x as A and x as B. But we need 2 here, isn't it? So write half into 2. So y is equal to half, right? So within bracket 2 sin, you write first 2x into sin x, bracket closed, right? Then write down sin 3x. Then you write down sin 3x, right? Or y is equal to half. Now within bracket. Now this is the formula 2 sin A sin B, isn't it? Here A is 2x and B is x. You can use this formula. That is cos of A minus B. What is cos of A minus B here? Cos of what is A minus B? 2x minus x is x minus. Then cos of A plus B. Cos of what is A plus B? 2x plus x is 3x. You know that, isn't it? So into what? Into sin 3x. Is that clear to all of you? Now let us simplify it. Let us multiply them. Or y is equal to half into cos x into sin 3x. But among these 3x and x, 3x is greater than x. So you should write sin 3x first. So half sin 3x cos x. Is that clear? Then minus, again you have to multiply half into cos 3x into sin 3x. What is it? It is half sin 3x into cos 3x. Is it clear now? So now in this case, how to simplify it? Now this is the form sin A cos B. These are two different angles. Greater angle is taken as A and smaller angle is taken as B. Greater angle as A and smaller angle as B. But these are same angles. This is sin A cos A. So here in this case, we can use the formula of 2 sin A cos B, isn't it? For this one, 2 sin A cos B, what is the formula? It is sine of A plus B plus sine of A minus B. You know this formula. You should know it, right? Next one is sin A cos A. Same angles are there. So it is 2 sin A cos A. We need 2 there. 2 sin A cos A. This is from multiple angles. So what is 2 sin A cos A? It is sin 2A. Is that clear? So let us use the formula in this case. But we need 2 in this case, isn't it? Before sin 3x cos x, we need 2. Before sin 3x cos 3x, we need 2 there. So therefore, y is, you should write here 1/4 into 2. That means we are multiplying both numerator and the denominator by 2. That is 1/4, make it 1/4 into 2. Then write down sin 3x cos x. Then minus 1/4 into what? 2 sin 3x. 2 sin 3x cos 3x. Is that clear? So let us simplify it once again. Or y is equal to 1/4 within bracket. So we have the formula out there. So it is 2 sin A cos B. What is the formula? Sine of A plus B should be there, isn't it? What is A plus B? 3x plus x. That is 4x plus sine of, what is A minus B in this case? 3x minus x. That is your 2x. Okay? So minus 1/4 into, what is 2 sin A cos A? It is sin 2A. But in this case, we have sin 2 into, what is the value for A here? It is 3x. Is that clear now? So this is the formula, right? So let us simplify it. Or y is equal to 1/4. This is sin 4x plus 1/4. This is sin 2x minus 1/4. This is your sin 6x. Is it clear to all of you? Now you can easily differentiate them. Okay? So write down differentiating both the sides. Differentiating both the sides with respect to x. Therefore, dy by dx is equal to 1/4 constant is with the variable. So you should write here 1/4 before d by dx. So it is d by dx of what? It is sin 4x. Next again plus 1/4 into d by dx of this is your sin 2x, right? And next one is minus 1/4 into d by dx of, it is sin 6x. That is 1/4 d by dx of sin 4x, we are differentiating it, plus 1/4 into d by dx of sin 2x, then minus 1/4 into d by dx of, this is your sin 6x, right? So now let us find out their differentiation. So, or dy by dx is equal to 1/4 into, how do you differentiate it? D by dx of sin 4x, that is, you should take it as sin x. What is the differentiation of sin x? Cos, here x is 4x into, again you have to differentiate the term which is assumed as x, 4x. What is the differentiation of 4x? Directly you can write it now, 4 into 4, you know that. How did you get 4 only? 4 into d by dx of x. You know that d by dx of x is always 1. So into, what should you write here? Into 4, right? Similarly, plus 1/4 into 1/4 into what is d by dx of sine 2x? You should take it as sine x. What is the differentiation of sine x? Cos x. But here it is cos 2x into, again differentiate the term which is assumed as x. That is, you have to differentiate 2x with respect to x. So 2 comes in the front. What is d by dx of x? It is 1. So what is the differentiation of 2x? That is 2. Is that clear? Next, minus 1/4. Similarly, what is d by dx of sine 6x? It is cos 6x into, again you have to differentiate 6x which is assumed as x. So what is the differentiation of 6x? That is 6 comes in the front into d by dx of x. That is always 1. Is that clear now? So let us simplify it. 4 1s are 4, 4 1s are 4. This is 2 1s are 2, 2 2s are 4. This is 2 3s are 6. This is 2 2s are 4. So what is the final answer now? Or dy by dx is equal to, this is your only cos 4x, right? This is only cos 4x plus, this is half cos 2x minus, this is your 3 1s are 3 divided by 2 into cos 6x. So this is the final answer. So I think you have understood it. So you can copy it. We'll do the next question now. So now let's do this question now. Find the derivatives with respect to x, right? So this is 13 number 12, right? So you have to find out the derivatives of this function, that is root over x square plus 1 minus log within third bracket 1 upon x plus root over 1 plus 1 upon x square with respect to x. Okay? So let us assume this function as y. So let y is equal to this function. Again, this is the given function. So let us simplify it first, right? So or y is equal to root over x square plus 1. It is kept as it is, minus log within third bracket 1 upon x plus within square root. What's the LCM here? X square. So x square into 1, x square plus 1, right? Or y is equal to, this is root over x square plus 1 minus log within third bracket 1 upon x plus, now you can get the square root of x square which is in the denominator, right? So in the numerator you should write x square plus 1 within square root divided by, what is square root of this x square? This is only x. Okay, so let us simplify it. Or y is equal to, this is your root over x square plus 1 minus log within third bracket. What's the LCM here? X. So here x is the LCM. Okay, so in the numerator we have 1 plus root over x square plus 1. Is that clear? So again, which property can you use here? Log of a by b. You know the properties of logarithm. What is log of a by b? It is log a minus log b. So or y is equal to root over, this is your x square plus 1 minus log of within bracket 1 plus root over x square plus 1. That is log a minus log b should be there. But because of this minus sign, that minus sign becomes plus. Actually it is log a by b, log a minus log b. But that minus sign will be changed because of this minus sign. So minus into minus plus, this is your log x. Is that clear? So let us differentiate it. So differentiating both the sides with respect to x. So let us differentiate it now, right? So now therefore dy by dx is equal to, you should write dy by dx, but in the previous problems we write d by dx of root over x square plus 1 and then differentiate. Okay, so but in this case you don't have to write d by dx of root over x square plus 1. Okay, directly you can differentiate it now. So no need of writing d by dx of within bracket root over x square plus 1 and so on, right? Just directly write down the differentiation of root over x square plus 1, right? So dy by dx is equal to, what is dy by dx of root over x square plus 1? Now don't write dy by dx of root over x square plus 1. Let us directly differentiate it. So root over x, it is just like your root over x, isn't it? So it is 1 by what? 2 root over x square plus 1 into. Again, you have to differentiate the term which is assumed as x, isn't it? Again, actually, we write d by dx of x square plus 1, isn't it? So here also no need of writing again d by dx of x square plus 1. Just write down the differentiation of x square plus 1 with respect to x. What is it? What is the differentiation of x square? It is 2x plus, what is d by dx of 1? That is 0. So will you write 0? No, you don't have to write 0 here because 2x plus 0 is always 2x. Is that clear? Now minus. Here also no need of writing d by dx again. Just directly differentiate that. Log within bracket 1 plus root under x square plus 1. So you should take it as log x, right? What is the differentiation of log x? 1 upon, it is 1 plus root over x square plus 1, right? This is your 1 by x. Which function is taken as x? 1 plus root under x square plus 1 is taken as x. Again, that function is to be differentiated. That is into d by dx of what? D by dx of 1 plus root over x square plus 1. Again, in this case also, no need of writing d by dx of 1 plus root over x square plus 1. Directly differentiate that one. Okay. So what is d by dx of 1? 0. No need of writing it. Plus, what is the differentiation of this square root x square plus 1? It is 1 by 2 root over x square plus 1. Is that clear? Is that clear? That is, what is the differentiation of this square root? It is 1 by 2 root over x square plus 1. Again, you have to differentiate the term under square root, which is assumed as x. Again, you have to differentiate the term which is assumed as x. That is, x square plus 1 was assumed as x. Now you have to differentiate x square plus 1 down. So what is the differentiation of x square plus 1? It is 2x. Third bracket is closed. Is that clear? Next, plus. What is the differentiation of log x? It is 1 upon x. Is it clear to all of you? So we have got this expression, right? So here you can cancel this 2 This 2 also gets cancels. You can cancel them. So let us simplify it now. Or dy by dx is equal to x upon root over x square plus 1 minus. So this is your x1s are x1s are x divided by you write first root over x square plus 1 within bracket 1 plus root over x square plus 1 bracket closed. Then you write plus 1 upon x. So I think you have understood it, right? So let us simplify the first two terms now. Or dy by dx is equal to, what's the LCM here? What's the LCM in this case? Root over x square plus 1. Both are same here. So only you have to write 1 root over x square plus 1. Because root over x square plus 1 and root over x square plus 1 is there. So what is their LCM? It is root under x square plus 1. You have to write only one of them. That is root over x square plus 1. Then into 1 plus root over x square plus 1. Right? So now, what will you do? What will you do now? What will you do? This LCM is divided by root over x square plus 1. These two will be cancelled. So it remains 1 plus root over x square plus 1. So it should be multiplied by x there. So x within bracket 1 plus root over x square plus 1. Is that clear? Now this LCM is divided by this denominator. That is root over x square plus 1. Root over x square plus 1 gets cancelled. You will have only 1 plus root over x square plus 1. So it should be multiplied by the numerator. That is x into 1 plus root over x square plus 1. Then minus sign is there. So now what will you do? Now this LCM is divided by both these factors. That means 1. It will cancel. That is 1. 1 into x is x, right? Then write down plus 1 upon x. Okay. So next, let us simplify the numerator now. Let us simplify the numerator, or it is dy by dx is equal to, what is the numerator here? Multiply it. x1 are x plus, it is x root over x square plus 1. Then minus x is there, whole divided by, it is root over x square plus 1. Then within bracket 1 plus root over x square plus 1. Then you write plus 1 upon x. Okay. So here also you can cancel this, x gets cancels, or dy by dx is equal to x root over x square plus 1 divided by root over x square plus 1 into 1 plus root over x square plus 1, then plus 1 upon x, right? So again you can simplify it further. This root over x square plus 1 gets cancels, isn't it? So, or what is dy by dx now? Or dy by dx is equal to, it is x upon 1 plus root over x square plus 1 plus 1 upon x is there, right? So let us simplify it further. So what's the LCM? Or dy by dx is equal to, what's the LCM here? So what's the LCM in this case? It is x within bracket 1 plus root over x square plus 1. This is the LCM. Now this LCM is divided by this factor, that is 1 plus root over x square plus 1 gets cancelled. What do we get? X only. So x should be multiplied by x. So it is x squared plus, right? Next, what will you do? Now this LCM is divided by x, x gets cancels. So it remains only 1 plus root under x square plus 1, right? So let us write, यो LCM लाई x ले divide गर्ने. तो x ले divide गर्दा x is the cancel भयो नि त. के रह्यो? 1 plus root under x square plus 1 रह्यो. त्यसले चाहिँ यो 1 सँग मल्टिप्लाई गर्ने. तो यो 1 सँग मल्टिप्लाई गर्दा कति हुन्छ? 1 plus root over x square plus 1. Is that clear? So let us write it within bracket. Can you simplify it further? We can simplify it further again. So how do we simplify it? Or dy by dx is equal to, now since this is root under x square plus 1, right? So can you write x square plus 1 within square root and whole square? Yes, we can write it, isn't it? This way, that is root over x square plus 1 whole square, right? So why are we writing this root over x square plus 1 whole square? Because you can take common out here. So plus, it is root over x square plus 1. This whole divided by x within bracket 1 plus root over x square plus 1. Is that clear to all of you? So I think you have understood it. So or dy by dx is equal to, what is common here now? From these two terms, what is common? Root over x square plus 1 is taken common. So within bracket, what do we have? This is whole square. One of these root over x square plus 1 is taken common out here. So within bracket, we have root over x square plus 1. Then plus, now this is already taken common out here. So it is 1. Whole divided by x within bracket 1 plus root over x square plus 1. Is it clear now? So we can cancel these two expressions. Or what is the value for dy by dx now? So dy by dx is equal to root over x square plus 1 whole divided by x. So this is the final simplified answer. So you can copy it. We'll do the next question now. So now we are doing the next question, that is find the derivative of the function sin to the power px divided by cos to the power qx with respect to x. So let us write let y is equal to this fraction. So here power p is a constant, here power q is a constant. So let us write it within whole to the power p and whole to the power q in both the numerator as well as in the denominator. So let y is equal to, this is sin x whole to the power p divided by cos x whole to the power q, right? So in this case you have to differentiate it, okay? So you have to differentiate both the sides with respect to x. Now you know u by v rule. So suppose you have d by dx of u by v, where u and v are two different functions of x. So what is the method for finding out the differentiation of this fraction with respect to x, where u and v are both the variables, right? So is equal to, what is the method now? Always you have to keep the denominator as it is. That is v into, take the differentiation of the numerator, that is d by dx of u. That is the numerator is differentiated with respect to x. Then comes minus sign. Now we have to keep the numerator as it is, that is u into, now take the differentiation of the denominator, that is d by dx of v. And according to the rule of the u by v rule, you should write whole divided by denominator whole square, that is your v square, okay? So what is d by dx of u by v? That is denominator v is kept same, d by dx of numerator minus, now numerator is kept same into d by dx of denominator whole divided by denominator whole square. That is the rule, right? So let us write here differentiating both the sides with respect to x, okay? So I think you know this rule, right? This is known as the quotient rule also, or u by v rule also. So first of all you have to keep the denominator same, take the differentiation of the numerator with respect to x minus, then numerator is kept same, then take the differentiation of the denominator, then whole divided by denominator whole square. Is it clear now? So let us differentiate it. Therefore dy by dx is equal to, now denominator is kept same, that is cos x whole to the power q into cos x whole to the power q, that is denominator is kept same. Now take the differentiation of the numerator. Now no need of writing d by dx of sin x whole to the power p, directly differentiate it, okay? So it is in the form x to the power n, because power p is constant and this base sin x is the variable. So let us take it as x to the power p. What is this differentiation? P comes in the front, sin x whole to the power p minus 1 into, right? Take the differentiation of the function which is assumed as x, that is you have to differentiate sin x. What is the differentiation of sin x? It is cos x, right? First part ko kam sakyo, then minus sign, then comes minus sign, right? Now which function is kept as it is? That is the numerator, that is sin x whole to the power p is kept as it is. Now differentiate the denominator now. It is cos x whole to the power q, power is a constant and this base is the variable. So you should take it as x to the power n again. What is the differentiation? N comes in the front, that means q comes in the front, then x to the power n. What is x here? Cos x whole to the power n minus 1. Decrease the power by 1, that means q minus 1. Again you have to differentiate the term which is assumed as x. So in this case cos x was taken as x. So cos x is also to be differentiated. You have to differentiate cos x with respect to x. So what is the differentiation of cos x? Into minus sin x, right? So whole divided by, according to the rule, it should be denominator whole square. What is denominator whole square? that is cos x whole to the power q whole square. That is the denominator whole square. Is that clear? So now let us simplify it. Or it is dy by dx is equal to, what is cos x whole to the power q into cos x? So if there is only cos x, its power is whole to the power 1. So if you multiply them, powers will be added. So you write first p. So it is cos x whole to the power q plus 1. Then sin x whole to the power p minus 1. Is it clear? Similarly, minus q is here. Write q first into, it is minus into minus is plus. So you can multiply minus into minus is plus. You first write q, then what is sin x whole to the power p into sin x? There is only sin x. Actually it is sin x whole to the power 1. If you multiply sin x whole to the power p into sin x whole to the power 1, powers will be added. That means sin x whole to the power p plus 1 into so cos x whole to the power q minus 1. You can keep it as it is, that is cos x whole to the power q minus 1 whole divided by what? That is cos x whole to the power what? You can multiply these two powers, isn't it? Cos x whole to the power q, again whole to the power 2 is there. So these two powers must be multiplied. So what do we get? It is 2q. So you can keep the answer as it is. No need of simplifying further. No need of simplifying it further, right? So this will be your correct answer. तो ये नहीं होती मेरे को correct answer. ठीक sir? So you can copy it. Now I'll give you some homework. So now these are your homework. From the same page number, that is 292 from the book Higher Mathematics for Class 10 by Sailendra. So this is exercise 3A. Each question carries 2 marks. So you have to find out the derivatives of all these following functions with respect to x. Okay. So you revise all the problems that we did today first. First you revise all the problems. Okay. Then do this homework. Then it will be easier for you to do all these problems, right? So this much is for today. So we'll do more questions in the next online class, okay? So this much is for today.